Hello, my name is Jason. I am doing project 2 for ANSYS fluid simulation. So we're going to start off with simulating 2D flow over a flat plate. So we start off with our geometry. I'm going to make this full screen. Start off with our geometry. We're going to make this 2D simulation. So we start there. I like to edit in Design Modeler, so we're going to load this up. And so now that application has opened up, we're going to sketch in the XY plane. Let's go to sketch. I'm going to sketch a rectangle. If I can get that point. Sketch of the origin, X and Y. We're going to go to our dimensions, horizontal. And we're going to make this, those are the wrong. Horizontal. Here we have this. Hello. Do I really have to do? Okay, that is our horizontal height, and then our vertical height. And so our horizontal height is going to be 1 meter exactly per the rules. And then our height we get to decide because of our fluid flow simulation. We're trying to see the boundary, and due to calculations, I have found that this number works best for our height. So now we have our rectangle that we get to simulate on everything. We're going to go to modeling, click on our sketch, and then we're going to go to concept, create a surface from the sketch, and apply. And then we're going to generate this, and then we're done right there. Next, we're going to go to mesh. Now that our application has opened up, we are going to go straight to mesh. We're going to insert, and then we're going to click on method. I'm going to click on our face for our selection and apply it. And we're going to generate it. We are also going to insert a sizing regulation. We're going to select on our edge right here. Select this edge, apply, and then create a certain number of divisions. This will be, we can make this around, we'll do 100 for our division, a hard behavior, and then we're going to create a bias so that we can manipulate how many little locations are in this place. So we're going to do a bias of 200. If we want, we can see that right here. Isolates down here. Might be able to do 70 right here. A little bit lower of a bias. We'll do 100 for both. And so here we get to leave that alone. Add another edge size on this edge. Apply. Same exact steps. Number of divisions. 100. Hard. And then create a bias. Same bias. Factor. But we are going to make this a reverse bias. I think if it'll let us, yeah, select on this, apply. And there we create a reverse bias where it's on the same side as we wanted. So, and then we're going to create our second to last sizing. We're going to select on this edge and this edge, apply. And we're going to make our divisions. This one will be very simple. 100 divisions. Maybe 200 divisions. 200 looks better. 300? Not 3,000. Too much. 300 works. Hard behavior and no bias at all. And then we're going to create our last mesh, which is the face mesh. Apply to this. And then we're going to generate the whole thing. we see that there's a bias near the bottom portions, and we see this whole mesh. And then we are going to title our edges. This one will be inlet. This one will be outlet. The top will be a symmetry. And then the bottom will be our plate that we are simulating 2D flow on. Here. And then update our mesh. And open setup. Click on double precision and start. Now that our application is open, we're going to set a few rules. We are going to actually first set up our model as laminar. Select OK. Go to our fluid and we're going to edit the properties of our fluid. We're going to make density 1.2 kilograms per meter cubed, and then our viscosity will be 1.8. Change create, close. And then we will go to our boundary conditions and we're going to set our velocity to 2. Apply, close. And everything else should be fine. Our outlet should be our outlet, wall should be our plate. We're going to ensure that this is stationary with no slip condition. Close. And then I think we are ready to run the calculation. We're going to do 300 iterations and allow it to initialize and calculate. We get a plot of our residual, and then now we get to start plotting the vectors. So this is going to be a filled arrow at every single location. Save and display. And we should see here at the bottom row the boundary layer. Yes, right here. Boundary layer in which this keeps increasing as distance goes on, and we see those different changes. And so that is one of the things that we needed. Another thing that we can look for here is the drag coefficient. And in order to find that, we go to, I believe it's either, yes, plots, XY plot, might be data sources. No. Well, another thing that we need is the shear stress. So we can go into the plot, go to wall fluxes, and here automatically we get wall shear stress where we can plot this on the plate, save and plot, and we see that right there. That is the wall shear stress. The other thing that we need to find is the wall flux is also the skin friction coefficient that we get to plot. Save and plot, and it looks just like that for both of those items. And one other thing that we are looking for is the drag coefficient. This can be found in report definitions. So we can go here, select new, go to our force report, go to drag. And here we can find our drag coefficient, and we want to find it on the plate. We select compute, and here we find it on the bottom in the command window. Here it is 0.0215, and that is part of what we need. Then we can start plotting some other things inside of results. Now that the application is loaded, we can start sketching some contours. So we want to sketch the vector contour, which would be very easy. The location will be about the symmetry and using velocity u. Apply 100 contours and apply. And here we end up seeing that contour. Here we see that exact shape that we want to see. Around here, yeah, that's the shape that we want to see. If it'll let me zoom in here, yes, that is exactly what we need. Then we're going to make our second contour, which is the pressure contour. Inside of the pressure contour, let's unselect the vector contour so we can see what is being selected. We want to use pressure. Our location will be about the symmetry. Same number of contours. Apply. And here we see this great big difference in pressure, especially around this location. That is one of the things we are looking for. The other thing we need to do is plot the vector profile at certain X locations. So first off, we're going to start creating a line location. This will be, we'll call this first line, which is at 35 centimeters, meaning our location will be here, 0.35, and then we made our height 2 centimeters, so that'll do that. Increase the sample size, apply. If we remove this contour, we can really see where that location is. Right there. Okay, so now that we have that line, we want to make our second line, which we will call second line. Second line will have a location at 75 centimeters. And this height is still the same. Apply this and we see that line come up. And for a third one, actually, I don't think we really need a third one. But now we can make a chart titled Vector Profile. Same title. In which it's line, use a data series. This will be first line, we add another page to plot these against it. Second line. And the x-axis will be the velocity u, while the y-axis is the y height. If we apply this, then we see this vector profile. And I think this is pretty important. And the last thing is that we can see that the boundary, the y boundary happens around, or the boundary layer, the height of the boundary layer happens around this location. So that seems to be around a little less than 1 centimeter. And then for this second location, it happens to be above around 0.015 2 in this area. And that is the project.